neural networks, or at least we're kind of gonna try that, I guess. So let's see what we have here. So first neural network. So let's go to 004. I have some cables here that are quite annoying. All right, so let's go to 004. Let's see what we have here. So we have simple data. We have Chris Ola. And we're gonna think about how we can visualize neural networks. I think I'm gonna get rid of the video preview. Yeah, so let's think about how we can visualize neural networks. So I really liked the post by Chris Ola. No, let's keep it nice and easy, and let's go to Superwork, because that has worked out pretty well so far. So Superwork, and we're gonna just fill it in, I guess. Yeah, so first let's prepare, then we're gonna set a timer. We're gonna work for 45 minutes, then we and then we take a quick break. So let's whoops, let's get this open. Oh yeah, so I passed my motorcycle. I passed the exam, and actually today I got my motorcycle. I got my license, and I took my first ride on a motorcycle, which was really awesome. It was really fun. It was a bit rainy, but it was really fun. So this is stream 11. Actually, it's not stream 11, but it's episode 11, but that's fine. Let's copy that. And let's make that stream 11, and that's at 29:11. So I haven't streamed that much, and for that I apologize. So what are we trying to accomplish in this stream? In this stream, what is a sensible goal that we can have for this particular stream? So for this particular stream, what I kind of want to achieve is okay, so what would be a reasonable goal for this stream? Let's think about this, because this is important, right? So it's important that we have a clear-cut goal of what we want to accomplish in this session. And I think that it would be cool to, okay, so what am I trying to accomplish? Let's try to, okay, no. So like, I want to visualize the decision boundary of a neural network. Visualize the decision boundary of a neural network. Of a trained neural network. All right, cool. Why is this important? Because I want to make a YouTube video in which I show what exactly happens when you train a neural network. And to make this animation or this video, it is necessary to have something to show that's really cool. Besides that, machine learning is awesome, yada yada yada. How will I know if this is complete? So, well, we will know if this is complete if given a trained neural network, we are able to draw a decision, probably in matplotlib. Any risks, hazards? Yeah, the internet, my phone, Reddit, social media, all distractions. I should have a water bottle somewhere here, but I guess not. Is this concrete or ambiguous? It's quite concrete, actually. Anything else noteworthy? Yeah. I took my first motorcycle ride today. It was great. All right, so let's start a timer. All right, so the timer is set. So what is the one thing I want to accomplish this session? So let's think about that for a second. What is the one thing I want to accomplish? So, so this session. Okay, so we have to make a very small goal. So the goal here is to have something that is so small that we can actually achieve it. And then we are motivated to do more. So the smallest goal I can think of is generate fake data, like generate the training data and plot it in Matplotlib. This is a very small goal and we can definitely achieve it. But at the same time, given that we complete it, I think it will be really motivating. And then say I were to finish this task, what is another task I could do? Another task that I could do is make the plot really pretty. So make the plot really pretty. All right. How will I get started? Good question. Make a new Python file and look up on Google and search Google for plotting examples. Hazards, internet, phone. Maybe that's about it. I don't have T, so that's a shame. Okay, so yeah, we have everything we need basically, so we can get started. So how are we gonna get started? By making a new Python file. So let's make a new Python file. So let's open tmux, make a new pane. We can type ls and l, whatever, and then we go vim. Excuse me. And go vim. Maybe something like viz and n.py, I guess. All right. So when did we? So this is not how you would usually create like. This is a very bad practice, but all right. Let's print hello world. Yes, I'm using Python 2.7. Python viz. All right, so that definitely works. All right, so let's make some fake data, I guess. So so to have fake data, how are we gonna do that? Let's think about this. So how did we have the other data, right? So let's have a quick look at the first neural network where we had main.py, where we defined a sigmoid backpropagation, and the data was literally X features and Y features. So X was an NP array and Y was an NP array as well. Yeah, so Y is the label, right? I think we can do the same thing. So let's import. So let's go there. So if name equals main. Oops. We can print world. Let's import numpy as np. X is np array, and then let's say 1. I think it should be a list in there. All right, so let's see if we can get this. Okay, that works. All right, so what kind of data are we looking for? So let's go to the plot and p-array. So matplotlib pyplot, the function plot is matplotlib pyplot.plot. So you want to do plot cplr plot show import. All right. All right. So let's see if we can plot this. So let's import matplotlib as dot pyplot as plt, and then plt plot x plt show. I'm wondering whether this is gonna work. Okay. Well, that's something. Oh, this is cool. Okay. So I kinda. So all right. So stick with me. So I'm gonna open Photoshop. Let's open Photoshop. Because this is what I kind of want to draw what I envision right now, right? So let's have a quick draw over there. Let's see if OBS is still up and running. OBS is still up and running. Very good. Stream quality is good. Audio is hopefully good. So let's make a new file. Let's make it 1000 by 1000, or width 500 by 1000. That's good. Then we're gonna zoom in a bit. We're gonna control and scroll. No, we're not. Control plus, sure. Then we're gonna make it black, and we are going to grab a nice brush. This is too big. Let's make it 1 pixel. That's too tiny. Let's make it 3 pixels. And that seems like a nice compromise. So let's have a nice yellow one here. All right, so what I envision, wait, no, let's actually do it in white. Okay, so for just this example, let's do it in yeah, let's do it in black actually. So this is kind of what I want to draw now. I want to have like an X and a Y here. And this is 0 here. Let's make this a 1. Let's make this a 1 as well. And what I now want to do is I want to take this red. And I want to kind of draw like maybe a sign or something. Something that kind of goes like this. And then I want to take a nice blue. Let's take a nice blue over here. That's more like cyan. I want a blue. And then I want to have a blue that goes kind of like this. Where they are like not linearly separable. So the point is that they should not be linearly separable. And then what we're hoping we can achieve is the following. So when doing this, what we hope we can achieve is, in the end, we want to make a decision boundary, right? So the goal here is to eventually, if I can actually draw it, let's see. I don't even think I can draw it in one go. So let's put this, fill it in, and then we're gonna kind of change it a bit. Kind of like that, I guess. Yeah, so the goal is to get something like this. So that's what we're looking for in the end. But then we want we kind of want this to be filled in. I have to get used to the controls again. So we want this to be filled in with a nice blue as well. So let's take that blue and fill it in, but reduce the opacity to like 20. And And then we have this red here, which is obviously really nice, but at the same time we want the... Let's make a nice path. Let's make a nice path. I think that's better. So then in the end, what we're hoping for is that we can get a nice non-linear decision boundary all in here. So make selection, and then we kind of want to fill it up and set the opacity also to 20. I'm gonna select this one. Gonna select this one. Select inverse. Oops. Select inverse. And I'm gonna remove that from this. So that is kind of the goal, I guess. Yeah. So that's the goal. So what I drew here. So that's what I want to do this tutorial, so to speak, or not this tutorial, but this session. So this is like the goal of the session. Excuse me. And then what exactly are these? So this thing, the blue line, is like training data. So training data, where like you have X, Y, and the label is 0. And and this is training data. X, Y, 1. And then this thing, like the boundary, and this blue thing, and this red thing in the end, those are the predictions made by the neural network. So predictions by neural network. So that's kind of a fleshed out idea of what I want to do this session. Yeah. So that sounds pretty doable. So that's kind of a more, so now it's down on paper, right? So now I of course I can change something, but now that we have it kind of written down concretely on paper, we can start working on it as a thing rather than as an abstract idea, right? So step one, of course, is generating the training data. So that's what we're gonna do this session. So this session, all we want to do is make 2 simple plots, and it should not take as long, but it's quite late already. Well, quite late. I mean, I usually program in the morning, so I'm not as sharp, but I'm pretty confident we can get a PyPlot to work and generate us some 0 to 1 algos. So let's think about what kind of functions we should use, right? So I think it should be a sine. Like this kind of looks like a sine wave, or like a parabola, like x squared, but we can use a sine wave, I guess. If we quickly think about the properties of a sine, so fx equals sine x, right? Runs from 0 to 2 pi, but so we can divide this by 2 pi, so we get sine x over 2 pi. So then we scale that to 0, 1, but then you get like, then you get 0 to 1, and then it goes from 0. Now it looks like this. So you have a 1 here, minus 1 here, but we don't want this actually. So maybe we even have to translate this. So if you want this thing, to be on top, that's this is like 2 pi. This is 1 pi. This is half a pi. So this is half a pi. So this is bad math. We should not do this. Let's call that f2, not f squared, but f2. Then of course we have to translate that. So let's do that. Oops. Let's make that f3, where we translate the x first. So we translate x minus half a pi, and then we scale it by 2 pi. So that kind of results in probably something like, so we get half a pi more, right? So now it starts at the top, then it goes down and goes down, and then it's like a cosine. We could have just used a cosine, actually. That's kind of silly. Yeah, so let's just use a cosine. We don't even need to translate a sine, so let's use a cosine, where x is scaled over 2 pi. But now still, as you can see, this runs between 1 and minus 1. So what we have to do here is we have to kind of squish it in. We have to squish in the original values. And we want it to be between 0 and 1. So if we kind of like, if we balance it completely there, no, we kind of want it to be between, let's say 0 and 0.75. So what I'm envisioning right now is that we have, so what I'm seeing, or what I'm thinking now, is that you have one of them is between 0 and 0.5. So one has to start at 1, I guess. And then it has to go down, and then it starts up at 1 again. And the other one, if you translate it like a little bit, but that's really nonlinear. Maybe if you can squish this one more. We can squish this one more. So I think that so this one starts at 1, but now we want to squish it from the bottom. So let's think about how to do that. How do you squish something from the bottom? Of course, this is like the amplitude, right? So what we could do is we could squish it completely and then translate it up. So we squish it with a certain factor, so we get the cosine of x over 2 pi times some factor, some factor, plus another factor. And I think we can just play around with that factor. So that's gonna be, those are gonna be our functions, I guess. And we can use different scalings for them, and then we can see whether they're actually learning that. So let's do that. Yeah, so let's make an NP array. Yeah, so all right, so step 1. Let's go here. Let's keep this open here. Let's keep this open. Hey, you want to kill me? What's up, dude? Hey, dude. It's so nice seeing you. I haven't streamed in a while, so I hope you still want to see me do math in Photoshop. I hope you do. Cause I'm going to, whether you want to or not. Yeah, doing math in Photoshop, right? So I'm making some nice drawings. Let's see if I can open them again. I can't seem to open them. Oh, yeah, there we are. So, what we want to do is we want to do this. So let's scroll up a bit. So that's our, yeah, doing really well, man. Thank you so much. I got my motorcycle license today. Like the actual license. So now I can vroom vroom on my motorcycle. So this is the plan for today. So this is our end goal. Our end goal is gonna be a picture like this. What we want to see is red line, blue line, our training data, and the red area and the blue area are the decision boundaries made by the neural network. So that seems rather doable, right? So right now, what I was thinking, like, what kind of functions am I gonna use for the red and the blue line? And I thought a cosine or a sine would be appropriate. Just a translated sine, maybe squish it in, maybe translate it up a bit, like fiddle around with the values. It's not too important. But so this is our goal. So right now, I have to make an NP array. Hello? Okay, so OBS says that it's working. So wait, can you see some non? Yeah, that's non-green screen. So OBS says it's working. Excuse me. Thank you, Ryagami, for the follow. I really appreciate it. It means a lot to me, personally. Yeah. So what did you guys miss? Because I've been talking for half an hour probably already with a muted mic, so that's kind of funny. So anyway, what I was saying was that so this is the main goal, right? So the main goal at the end of the stream is to get this kind of a picture working, but then where we actually made everything. So we have to do three things, or rather, we have to do a couple of things. So we have to make a training data set, right? And that's what I did here in Photoshop, just thinking about like what kind of functions can we use to quickly make some data set. And I think I settled on like a cosine. I could have also settled on, I don't know, like just a linear function, but I thought a cosine was nice because then you could get like a non-linear decision boundary. And I hope that when we train the neural network, you see that evolve. So the red line is training data that we have to make. The blue line is also training data that we also have to make. And then the red and the blue areas, or the areas, those are the predictions from the neural network. So what we're going to do is we're going to divide up the whole 0 to 1 in like 100,000 points or 1,000. And then for each and every point, we're going to use the algorithm, the trained neural network. So it's trained by trained. To make predictions for, so, and then if it predicts a 0, we make it blue. If it predicts a red, we make it red, and that's how we get this thing. And now what we hope for is that we can do this for each different training iteration, and then like during the training, we hope that we can see like the decision boundary move around, that we can see the decision boundary shift. So that's kind of the main idea. Yeah. So let's make training data. Simple plot of, no, I want to make let's say NP linspace, I guess, or NP arrange. Let's see. Probably NP difference between linspace, because linspace is from MATLAB. So I've used a lot of MATLAB. Log space, linspace. Okay, so linspace seems nice, NP linspace. So let's see what docs, I guess. Returns evenly spaced numbers over a specified interval. Start, stop are both included. Endpoint can be excluded. So we have 0, 1, and num is, default is 50. All right, cool. So let's do that. So yeah. So let's say X blue, or just X actually. So X is NP linspace. 0, 1, num is, let's say 100. And then we have Y red, or Y1. All right, let's see. Y is, let's say, NP sine. Does that work? Does this work? Let's see. Probably not, but let's see what happens. Okay. Okay. I guess that works. But we said 2 pi, right? So 2 times pi. Is this a time sign? 2 times pi? I hope it is. Oh, okay. So can I quit this? Can I quit this anyway? Keyboard interrupt. Hello? How to interrupt. How to interrupt plot show. Is there any way to... Block is false. No, I don't want cookies, but... Okay, I should stop scrolling so much. Why is this website so slow? Why can't I scroll? Where's my scroll? Oh, whatever. I'm just gonna forget about this website. Close image. Yeah, hey, thank you, Pushup84. Thank you for joining me today. I don't think I've seen you before, so I'm really happy to have you. I know I want to close the image, but like, okay, so then it completes. So anyway, it works. All right, so let's compile this. No next window. Pi is not defined. Why is pi not defined? Import numpy, imports pi is not defined. That's weird. My name. Import math. You need math. Math.py. Huh. Alright. Cool. So import math pi as pi. I guess. No margin in pi. Import math. Import okay. That's weird that I so x is between 0 and 1, this is between 2 pi. Oh wait. Actually we have to multiply it. We have to multiply it by 2 pi actually. We don't have to divide it, we have to multiply it. Yeah. Alright, there we are. Look at this. From math, import pi. Alright, so let's try that actually. So, running. And then let's say we are finished. And then we are plotting. Import math, so from math, import pi. Let's see. 2 times pi. Alright, that works. Awesome. I kind of, so how do I put the grid on? Okay, so what if we now like make, I don't know, like 10 points, right? Does it still make, okay, so it kind of interpolates. So that it interpolates through the points. Okay, that's reasonable. Okay, but we want to squish it, right? So we have y so I'm thinking a bit longer about this because I'm trying to think of good variable names, right? Because we want to scale them, like in this, like we do here. We want to scale them, right? But I think A and B are kind of are bad names, right? So here we have scale, and this is translation. So trans. So scale and trans. That sounds like a nice. So let's make it. So because there's a parameter, so it's scale and then red, scale, or 1 and 0, and trans 1, trans not. That seems like better names. So let's give those a 0. Let's start them out with 0, 0, 0, 0. And here we have like y1 and y not. But then what is y1? So what does y1 look like actually? Now what does y1 look like? I don't have to. Oh, it's still open. Okay, so y is not defined. Sure. So let's make this y1. All right, and then we do this, and it doesn't print finished. Huh? Okay, so that's I guess it's just a 1D array. What is it? Wait, I should be able to see that. NumPy returns evenly returns an ND array. All right, so what does? Okay, so I'm gonna be honest, and I don't know what ND array stands for, but I'm gonna find out now. So ND array, n-dimensional array. Okay. Okay, cool. Awesome. So this is gonna be parameters, so like red parameters, and these are gonna be like the blue parameters. Right. So, but now instead of that, instead of like having A and B and D and C, we now have this times scale 1 times plus trans 1. Maybe I should call it bias or scale. Maybe scale not plus trans not, right? So hold on. No, so if I now plot and then POT plot x, y is not, but we translate this down to like -1 and then it's to maybe 2 or something. Let's see what happens. All right, so let's make this red. This should work, and this blue. All right, can I add a legend? It's some. I don't need. So the red line is wrong, right? That's 1. So I do, yeah, because I have the scale is not. So let's put the scale to 1. But no. So if we now go back to the picture, we kind of want to squish this, right? We want to squish this to like roughly a half. So that's like a factor 2 that we scale it. So we scale it like to a half. So if scale is a half, and let's say this is all. Let's make this like a third and see what happens. So we have to scale blue. We have to scale it. Let's say -1/2, and let's say this we keep it. And let's see what this gives, right? Okay, that didn't work at all. Wait, -1, 1. Okay. Trans is not. I'm kind of confused why it's not working. Probably something that I do, that I add like a number to an array and then everything breaks down. So let's print y1 and see what happens, right? So y1 is all zeros. So y1 is all zeros because scale is a half. Okay, so that's kind of odd, but that's probably because of the reason we think, right? So let's do this first. Let's see what this looks like. Okay, that's good. And now we multiply that by, let's say, 20. And now it all turns... no, it still works. If we now multiply it with scale 1, it turns into zeros. So that's odd. And that is odd because 1 over 3, of course, and 1 over 2. Look at this. 1 over 2 is 0. 1 over 3 is 0. Remember, guys, Python lol. So we're gonna write that down in things we've learned today. So things we've learned. In Python 2.7, 1 over 2 is 0 and 1 over 3 is 0. Of course, so that's because we divide two integers. And we have to make it like either, I think, 2.1.0 or, yeah, let's make it 1.0. And now, yeah, thank you, push up. You're right. Now we should, let's exit and then do this. Ah, beautiful. But at the same time, I kind of want them to stay in the 0. I want to keep them in the 0 to 1 range. Okay, so this is actually like, this doesn't even matter at all. So I'm wasting time here. Well, I don't want to say wasting time, but I could spend more time like axis 1. So okay, so we could use our time better. So let's make, I don't know, whatever. Just, okay, one of them starts from 1/4 and goes to, I don't know, here. And the other one goes to, or can we make a parabola? Or maybe a function like that. Oh, so this also works, right? So this is fine actually, but now it's not in between. Now it's not in between 0 and 1. Do you think that's gonna cause issues? The fact that it's not between 0 and 1. And note that I used the sine, and I should have used a cosine actually. So let's use a cosine. Oops. Ooh, I just shut everything down. Oops. So cd documents projects 04. Maybe tmux. I could attach it to the so can I ooh. Okay, so it still exists, right? So that's really nice. So wait, I hope you guys can see this actually. Is it not like, isn't the visualization goal in front of it? Like, don't you guys mind? Let's see. I'm just putting myself on the other screen for a sec. So if I like put it here. Okay, now you guys, if it's annoying, tell me if it's annoying. All right, so we plotted it and cosine. All right. There's no attribute cos. It's cos. So we noticed that the y-axis here is not between 0 and 1. And I'm now wondering whether that's going to give us problems. But it shouldn't be, right? It shouldn't give us problems. But yeah, I think I want to up the scaling of the blue one a bit, just a bit. Oh my god, I did it again. I thought I would shut down the... Oops. Alright, so let's attach again. So, cd documents project 04, and then tmux t, no attach, session, or attach t, and then session 2. Alright. Let's zoom in again. So let's change the scaling of the blue one a bit. So we translated it to a third, but let's keep it. What if we just make it a 1? Let's see what happens. All right, that's cool. If we now, is this okay? So this is cool. So now this you cannot separate this with a linear boundary. So you have to use a non-linear boundary, and that's exactly what neural nets are gonna provide us. So actually, I think we did that. So generate the training data and plot it in matplotlib. So we actually did that. I want to add labels. So let's add labels. So add label numpy plot. Plot, and then label So let's shut that down, and then label equals 1, label equals 0, and that works. But handles equals red patch. Okay, labels are not that necessary actually, so we can get rid of them. Redo. Scale is 1. Okay, so that's good. Okay, awesome. So that's step 1. Generate the training data. Okay, we generated the training data. So we are finished with our goal. So we generated. But now what we have to do is that we want to put this in like we need to make like a training data matrix, right? So what we're now going to do is we are going to upload all the points in there. Now we're going to make a training data kind of matrix, I guess, where we have just all the XY pairs along with the label. Or rather, we have the XY pairs and we have all the labels. So, oh, the timer is done actually. Okay, so we did a surprising, it took us 45 minutes to make a simple plot. So my productivity isn't necessarily that sky high, but I'm glad we started. So we got started. Any distractions? No. Things to improve next cycle. Please tell me. We generated the training data, and that's about it. So next session, we want to turn this into a matrix. We want to make a matrix with the data and the labels, just as in here, I guess. Here we made it like X's is our data, right? But so one observation would be, wait, I'll just open this real quick. So in the next session, or what we're gonna do, I'm gonna make some tea in a whim. So I'm gonna copy this real quick. So let's copy that and edit to this. So pasting is always a fun thing in Python in Vim. So let's copy that and then we paste it, and it's gonna look horrible. Yeah, that looks horrible. So what we want to do is we want to make training data. So next up, make training data. And the training data looks kind of like x equals like MP array, and then you have like rows of xy, and then you have another one xy, etc., etc., etc. And then the y, or the labels, so actually maybe I should name this label, I guess, will also be an array, but just a 1D array with like ones and zeros, where so that's for the next session, for the next 45 minutes, after I come back from a break. So step 1, make an array. We did that. Things we've learned. Python is silly. Yeah, so 1/2 and 1/3 is equal to 0. So you have to add the dot. So next up, what we are gonna have to do is we're gonna have to make an x. I don't like that we are using it. I'm not sure if I should keep calling this x, but I think I think it's nice that x is your training data, right? So let's not make this. Let's call this like linspace, maybe, or space, or range, x range. Does that sound decent? Or am I ruining everything now? So let's see, x range is y1, y0, and then we combine these into x equals and y equals. So these are the training data. And then we are not using any test data, so we are just going to use training data. We're going to overfit on the training data such that we can really capture like the whole essence of everything. So I'm going to keep this open. I'm going to keep this thing open here because I think it's a nice image. I'm going to keep this code open such that it looks like that we're doing something. And I'm gonna, I think, maybe add the T break sign. Break. Oh, oops, that's a big break. I want a small break. No, I want a T break. Music break? No. Where's the T break? Oops. Here's the T break. So T break. That's a bit big, so let's make it a bit smaller. T break. All right. Yeah, thank you so much for tuning in today, guys. I really enjoy having all of you. Well, I don't know how many viewers I have, but I hope it's one. Because I hide my viewers such that I don't know, I don't get distracted. So thank you all for joining me today. Our end goal at the end of the stream is to generate this picture, and we already have something, right? We already have something to show. I don't want to say we're almost there, but we already got a significant portion. Oops, x is not defined. That is true because we need to make it x range. So we already got somewhere like a bit. So let's keep that open. And this should be yeah, I'll be back in 5. So thank you so much, guys, for tuning in. I'm having a lot of fun. I hope you guys are, and I'm happy to have you guys. So I'll be back in 5. I'll make some tea. I'll put a counter. So stay tuned. again. It's kind of weird. Sorry. It's kind of weird that I have to plug it in and plug it out. But thanks for notifying me again. I appreciate it. Excuse me, sorry. So as I was saying, you can hear me now, right? I hope you can. I checked my OBS and it says it picks up the mic. So at the end of the stream, our goal is to get kind of a picture like this, and we already have 2 out of 3 elements. We already have the red data, we have the blue data, and now that all we have to do is make like the kind of how do you say that? The red and the blue areas. So yeah, so what I want to do now for so my what I'm thinking in my head is that I first want a working prototype of this image. And this is going so this is going to be generated by the neural network, right? In the end, but that doesn't necessarily mean that we need to use a neural network right now. So right now what we can just say is let's make this a parabola, and then if y is larger than the parabola value, return 1, otherwise return 0. So that's kind of what I want to do now. I want to make a function that can plot all the points on the decision region. So on the x, not x range, but the, let's say, so I just want to make a red and a blue region. That's it basically. So what I'm first gonna do is I'm gonna make another plot. I'm gonna plot a single wait, I have to first quit this plot. Then I'm going to make a single plot of another one. So let's say PLT plot x range and then y1 plus y2, y0. So I'm pretty sure this is going to give an error, but it's always worth a try, I guess. So let's see what we have. Okay, so that actually does work. Of course, you have 2 arrays. And what I now want to do is I want to first I want to make the alpha. I want to make it transparent because this is transparent, you see? So what I want to do is I want to make so this is like 20% opacity in Photoshop, which is a nice number. And I want to make like a scatter plot. So the idea that I have here is that we are just going to make a very rough grid of scatter points. And then say like that. And then for the red as well, right? And then we just set the opacity to lower. But instead of the scatter points being so far, we are going to make them really small so it looks like a real boundary. So we're just going to evaluate like, I don't know, 1,000 or maybe 100 by 100 squared. So that's 10,000 points. That's not too much. That's actually extremely doable. So first things first, I need to fill this in because I started the timer. Yeah, I started the timer already. So what is the one thing I want to accomplish? I want to make a plot of the decision boundary not made by the neural network. That will come in the next session. So say I were to finish this task, what is another task I could do? Make either the plot nicer or start working on the neural network. How will I get started? I don't know, Google search for alpha values plot. What hazard? Internet, phone, the usual. All right, so how do I get started? Google search for alpha values. So well, let's how to make a plot transparent MATLAB. Or not a plot, but how do you make a I think it will add transparency to objects. All right. This is wrong. I want MATLAB, of course. I don't want. Why did I type MATLAB? That's just pure muscle memory that I type MATLAB behind it. It should be PLT, of course. Matplotlib transparent line plots, exactly what we need. So let's see what we have here. Wow, that's a crazy plot. That looks really cool, actually. This is LaTeX. You can add LaTeX in Matplotlib? That's pretty cool. This looks like an orbit or a black hole. It's trajectories, huh? Alpha. Look at this, alpha. So it's just an alpha is 0.2. Yeah, let's see what happens. Awesome. Okay, yeah, okay, so this is basically like the training data, right? Or the not the like the data generating process, I guess, or data generation, which we are gonna turn into training data. And here we have the decision boundary values. So here we have X decision and Y decision. These are the X and Y values. So so this is just a linspace between 0 and 1. Let's say of 1,000 points. That sounds reasonable. And now we can plot that actually. So let's so let's plot X decision and Y decision. Okay, now I have to think a bit because okay, that's odd. Let's see. Oh, of course. Wait. No, wait. We need a lot more. So we need to specify like a grid. So we need like not an array, but a grid. So let's make a unit grid, numpy. Let's see what this results in. Mesh grid. mgrid, numpy mesh grid. All right. Coordinate matrix. Let's see. Okay, so this is, I think, kind of what I want. Sparse. Mesh grid is very useful to evaluate functions on a grid. So, so let's say we have linspace 0, 1, num is 1,000, 1,000, right? We can name these nx and ny. And then we say xv decision. Let's make a decision deck. Or maybe D or something. XVD. That is not... Let's keep it decision. Let's not confuse ourselves. XV, so for vector or field. So XV decision, comma YV decision is NP mesh grid XY. And now if we are is very useful to evaluate functions on a grid, because this is what we want. We want to return. So we want to return like. Yeah, now we're gonna write so for point points, you wanna like plot red if function returns 1, plot blue if function returns not. So that's kind of the pseudocode that we wanna use in the end. So this is not gonna run, of course, because it's pseudocode. But this should run, I think. So let's see whether this runs. X is not defined. No, because it's X decision. And it's Y decision. All right. So that definitely works. But we don't want like can we now? So, what is X view decision now? Let's see what this is. This is now a So does anyone in the chat know a smart way of iterating over a grid of points? What's the best way to iterate over a grid of points? So okay, let's think about that for a second, because we need it. It needs to be. It doesn't necessarily needs to be fast, but it's nice if we can make it fast, right? So let's see what we got here. So let's make this a 3-pointer. So we want to input a point. No, wait. So the question is, what is the input? Do we want to input a single point, or do we want to input the whole mesh grid? I think the easiest thing would just to input a point. So we're going to input an XY value, and then we are going to plot either like plot red or blue at that position. So that is a function. So that is a function. So let's make that a function then. Let's shut this down. That is a function. So we don't even need the mesh grid then. So let's make a function. So def plot decision xy, right? So you input xy, return not, I think, or I don't think it has to return anything. Maybe return hello. Can you return a string? No, right. Return not. Like, do you have to return something in Python? So let's call plot decision x decision not, and y decision not. Plot decision is not defined. Plotting, so you don't have to return anything. Okay, so if I now do PLT plot x, y, so if y equals larger than half times x, PLT plot xy red, else PLT plot xy blue. All right, so I don't see anything. But of course, because 0, 0 is here. So let's actually make this like -10 or something, like -5. -5 to 5. But now it's probably no. This won't work. Yeah, I want to find functions that are in between 0, 1. We're gonna have to fix that. But we wanted to kind of constrain it to the unit square, I think. Yeah, I think we want to constrain it to the unit square. Yeah, so I'm gonna write something down now. Because like in this session, so in this, hey, just me, bro. What's up, man? How you doing? Great to have you again. So in this session, we are only looking at the outputs. Yeah, long time no see, man. It's like 5 days. It's been 5 days. I was busy with some other stuff, so it's been 4 days actually. So, yeah, we've been busy with a lot of stuff. So happy to have you. So today the goal, you're coming at the right time. So the goal of this stream is to make like a picture like this, where we have training data, and the decision boundary generated by some algorithm. So right now we're working on generating the decision boundary without a neural network, but we want to make it the neural network. And then the end goal is to kind of get an idea of like how the neural network learns. No, it's not neural style transfer. This is just a standard neural network. So the idea here is that we want to make a picture every time we update the weights, and then we want to see how the decision boundary changes as the model learns. And that is exactly how a neural net learns, right? So wait, what was he doing again? I was plotting some. Okay, so how do you make a marker size? So increase marker size. Let's Google that. NP PLT plot increase marker size. Marker size. PLT plot marker size. That's probably a parameter. Field marker. Let's see. It's a scatter, so scatter scatter S is S. So let's try scatter. And then S is 10? Nah, S is 4. S is 4. Scatter got multiple values for keyword S. How do you... It's the area of the marker. Okay, so see. Okay, this works. Oh, look. So here we have. We can zoom in here actually. Look at this cute picture. How cute is this? So let's make that a bit bigger. Let's make it like 1,000, I guess. Scale is 1,000. So S is or marker scale. Awesome. So okay, so this is okay, got it. So it's like a CNN DIY. Well, not really. I wouldn't call it a CNN. it's just an NN. It's just a neural network. So the main idea is that what I want to show here is how a neural network is trained. So if we go back to this, if we go back to Chris Ola's article on neural networks, so this is kind of what I want to make, I guess. I don't want to copy it. Well, I'm not even sure if he does exactly what I want to make. So he has this, right? And then this is a linear boundary, but then as it learns, it kind of updates, and then in the end you get this kind of a boundary. But what I want to show is you guys is how it goes from this to this, like how it learns, like that's kind of what I want to show you guys. So like how do you go from a linear boundary to a nonlinear boundary, and what happens every time you update the weights? Yeah, so we did this. We discussed this like theoretically completely, and here we were. So back then we were talking about squishing, and stretching and squishing, but that is not what we're gonna do. I actually thought about that. That's a good point you make. That is exactly not what we're gonna do here. So we are not gonna do this, because what this does, this dives like into the neural networks. So if we remember what this picture did, this picture dives like into the hidden layers. So we go from the input. Hello? Now it should work again. It's weird that it drops on. Maybe I have too many USB things plugged in. But thank you, G Louise, for the follow. I said that, but maybe you missed it. I really appreciate it. You're my 66th follower, so that's really nice. Thank you so much. So what I was saying was, let me get rid of myself. No, I'm gonna keep myself on actually, but I'm gonna disable my preview because I don't want to look at myself. No sound? Okay, so the sound's back now. So when we discussed this tutorial in the, which stream? We discussed it in one of our streams. We were talking about how we stretch and then squish the space, right? That's really mathematical. It's about like topology, but that is exactly what we're not gonna do. So what we are gonna do is we're gonna stay in the original data space. We're not gonna do any crazy stuff with stretching and squishing the space in which the data lives. No, we're only gonna look at how does the blue area here turn into the blue area here. And with every weight iteration, so we do a feed forward through the whole network, then we do a back propagation backwards, we update the weights, right? So that is, and then the decision boundary changes. And what I want to show you is how that decision boundary changes every time. So that's the goal. That's kind of the goal, what I want to show tonight. That's the end goal, which I think is really nice. So we were working hard on that already. And we made a nice big blue dot. All right, so now we have to make a lot of big blue dots. Yeah, let's turn that down a bit. Let's say 500. This is all just fiddling around. Maybe not even 500. Maybe just 100. All right, and now we want to iterate over all the points. So Is a NumPy array, can you iterate over that? I actually don't know. Let's find out. For x in x decision, plot x. No, print x. Let's see what happens. Okay, so that's definitely possible. So that means that we can also, for y in y decision, we can just plot it. So we can just say like plot decision xy, right? And now we are gonna get oh, this is cool, I guess. No, wait, I'm gonna shut down this. Then we are gonna set the alpha. Let's set the alpha equals 0.2. Let's do the same here. And then we actually want to do this first. Wait, we are doing that first actually. So from here on we start plotting. All right. It didn't save. All right. So okay, so now it's plotting because it's taking significantly longer, right? So because we're plotting 100,000 points, or maybe 1,000, I'm not sure. Hopefully my PC won't crash. All right, now we wait. Because now we are plotting the individual points, right? This is taking too long. So let's think of a better way to do this. So okay, so let's first so that's 100 that's 1,000 points, that's 1,000,000 points. Okay, so let's do it with 10 and see if it works. I'm pretty sure it does work, but I want to use a different method actually. Yeah. So so it starts at 0. Yeah, it goes, yeah, okay. So actually I have a different idea. So what I'm aiming for in the end is kind of the fall. Maybe can I? Is it okay? So I'm thinking like I have 2 or 3 streams that are going through my head at the same time, which is bad. So I'm gonna focus on one thing first. So the first thing that I notice is so let's do one thing at a time. So the first thing I noticed was that these things overlap. So oh, they actually don't overlap. So I just want to plot a region. So I want to plot region Python. Plot decision region, for example. Plotting decision regions. How to plot decision region. Well, that's neat. People have thought of this already. All right, mlxtend plot import plot decision region. Yeah, exactly like this. Density grids. mlxtend plotting plot decision region. So what is it? But there we have to input. Okay, so my second idea was that we want to make a function. What we in the end we want to do is we want to plot this. So POT scatter. Then we have like x red, y red, alpha equals 0.2, and we have x blue, y blue. But then we need a function, of course, that returns x red, y red, and the function also returns x blue, y blue. Which is given by get decision region, x decision, y decision. So the idea behind this function is that we don't plot all the points, but we separate the x's and the y's into x blue, into x red, x blue, and y red, y blue, and then we plot them in I think that's significantly more efficient. So what we now have to do though is we have to make a new function which is called get decision region. Marker scale is not that. Yeah, so let's add that there, and then we say, all right, so C equals red, right? C equals blue. Let's see, marker scale equals, no wait, S is marker scale, and here we have S equals marker scale as well. But what we now want to do is we want to make the function called get decision region, where let's make this a big X, this is a big Y. So now we're gonna check. So for can you iterate over tuples? This is a good question. So for xy in xy, print xy. Okay, I'm not even sure. I wanna like loop over tuple Python. So iterate over two arrays Python. How to iterate through two lists in parallel. Look, people already had the same problems. Zip. Zip, zip, zip. Okay, we need zip. So I think we've learned zip to loop over two arrays in parallel. Now it would be awesome if this works immediately. I highly doubt it. I'll probably run into some error. Let's see what we have here. So for xy in xy print. All right. Non-type is not iterable. That is really cool. It actually works. So, and now we want to return x red, y red, x blue, y blue. Okay, and now the question is, how do we append to an array? Okay, so append to numpy array and p append maybe. Values are appended to a copy. These values are extended as a copy. Append. Okay, so we know how to append. Now the question is, can you append to an empty array? So if you do numpy append on something that doesn't exist, so to a copy of this array. Append does not occur in place. A new array is allocated. But that will be very inefficient then. Insert. If we do that 100 times. Insert values. A copy does not, okay, so it never does it in place. Okay, so now how do you initialize an empty array? Initialize empty array numpy. I think np array and then an empty list. Numpy empty. How do I create an empty array? Hello? Okay, so the sound is working, yeah. You have the wrong mental models. Is zeros, but we don't know how big it is. Just an empty list. Okay, so we need like an empty array, right? So we cannot do without. So let's say xred equals np array and then make an empty list. And then we can append, so np append xred, and we're gonna append x. And now let's get rid of this for a second. No, wait. So x blue is np array. Y blue. Y red. Okay, let's see if this works. Y red's not defined. Sure. It's fine. Okay, that definitely works. Then what we have is that we need to append, right? So let's print xred and see what it looks like. That's empty. Okay, so xred is empty. We gotta keep that in mind. So that did not work. Because we should put it in a list, probably. Values. These values must be correct shape. If we put this in a, this is gonna error, I guess. This is not gonna give an error, but it should not work actually. So np array, I don't understand why it's not. Oh, because it, okay, so it returns a copy, right? It returns a copy, but then we overwrite it. So now it should definitely work. No, it doesn't. Okay, but look at this. We did manage to add it to the list. So that's really nice. Now we have y red, x blue, and y blue, which we all want to append. Y red, x blue, and y blue. Not in capital, just a small one. X, y, x, oops. No, x and y, yes. So and here now we're gonna have the function. So right now, this is a random function. And this is gonna be a neural net prediction in the end, right? But right now, this is just a complete random function. So if, let's say, x is smaller than np square root of y, then we do this. And else, we do this, right? All right, awesome. So now it should work, actually. I hope. It doesn't. So y red is a capital. I have a big Y somewhere. I have a big Y over here. Two big Y's. Oops. Awesome. Is it awesome? Hey, Greenie. How you doing? So nice to have you, man. I have to admit it's a bit buggy because, well, let's think about what we learned today. We learned that we cannot just do this. Wait, we can actually. Okay, so let's make it if x is smaller than yes. And x equals 0. Oh yeah, of course. So what I'm looping now over is I'm now looping over 0, 0, 1/10, 1/10, 2/10, 2/10. So I'm only looping over the diagonal. I think I do need the mesh grid actually. But then I should be able to just plug in the mesh grid. Yeah, so let's try making the mesh grid again because we decided not to do the mesh grid, and then we are gonna use the mesh grid. So let's go numpy mesh grid. Let's see how much time I have left. I have 60 seconds left. Okay, so 60 seconds of figuring out what a mesh grid is. Mesh grid. We'd used that already. So we had the lint space, and then we can do xv decision and yv decision equals using superwork every day. Wow, that is awesome, man. That is really cool to hear. Yeah, I haven't streamed in 5 days or 4 days. I forgot. So you've been using it for 5 days. I'm so glad that it helped you, man. Or at least I hope it's helping you. It helped me a lot. So yeah, great, man. That's awesome. It's really cool to hear that that it made something that you found useful. It's really awesome. X decision, Y decision. Yeah, feel free to share it with your friends and link them to my stream. Nah, that's a joke. But feel free to share it with your friends because yeah, spread the love, man. So that was the timer. I just gonna save this and see whether this works, whether we get the mesh grid. Okay, so this is fine because we want and now we're gonna try and throwing in the xv decision and the yv decision. I'm not sure. I'm very doubtful that this is gonna work because xv and yv are like matrices. So okay, I'm gonna run this. It's gonna give an error. I'm pretty sure about that. Yes. And now we need to flatten this. We need to flatten a matrix. So let's see if we can flatten this. Flatten numpy array, I guess. NP flatten maybe. Oh, it's just Oh, oops! Almost spilled tea everywhere. So let's print xv decision, and then let's print xv decision flatten. And it should, yeah. So see, look at this. This is like a matrix of a matrix, and now we flatten this, and excuse me, and now we can also flatten this. Excuse me again. So if we now flatten, and we flatten this as well, now it should maybe work. Awesome, awesome! Look at this. This is awesome. All right, so now all we have to do is up the number of points, and we actually get a decision. Oh, and it might take. Oh, yeah. Let's not print everything. But this should definitely work. Awesome! Look at this. Sorry, I'm excited. Look at how awesome this is. Oh, Jen, I have something to share with you. Awesome. I'm eagerly awaiting your what you want to share with me. So wait. So the alpha. Let's put the alpha. Let's make this 100. Okay, let's put the alpha down like a notch. Like, let's see. Awesome. Awesome. All right, so let's open Photoshop. No, wait. First let's fill in superwork. So let's see. Wait, first I'm gonna wait, what's the time? Time is 8:20:06. So the goal was make a plot of the decision boundary not made by the neural network. That actually took 45 minutes to figure out. Okay, so we actually did that. So let's see, what kind of things we used. So we made a mesh grid of the points, which we then separated into red, blue, and then plotted after flattening the arrays. We made the decision boundary. So right now, any distractions? No, I looked at my phone once, but that's fine. So right now the decision boundary is this, right? So this is the decision boundary right now. This is the decision boundary. It's a random function. But what we want to change this to is the prediction of the neural network. So right now it looks like this, and in the end this is our end goal, right? So we are actually getting quite somewhere already. That's pretty neat. So just to recap for those who missed it, if we get rid of this for 1 second, we have just some. This is our goal. So the red line is just trading data, which has label 1, which we paint red. Then we have the blue data, which is also generated trading data, which has a label of 0. And the blue regions and the red regions are the decision boundaries made by the neural network. So for every point in this grid, we're going to check, what does the neural network predict? Is it red? Is it blue? And then what we hope we can visualize is how the decision boundary changes during training. So that's the ultimate goal. We kind of want an animation. We want to make an animation of how the decision boundary changes as the model learns and as the model progresses. So that's the goal. I'm not sure if I can finish because I have to go after the second session, I'm afraid. After next session. I thought I had more time, but it turns out that I actually only had 3 or 4 hours to stream. So yeah, wait. Now I'm gonna check out your link, and then I'm gonna check out your link. I actually opened it already, so let's put it on the big screen. So let's see. Release only subscription. Sure. Physical visualization. Ooh. Oh. Ooh. Wow. Wow. That's all. Wait. How many stars? 50 stars. It's seems underappreciated. Yeah, that is really awesome. Like, so that is a thing. So this is something that I also wanted to do. Like, this is exactly what I wanted to do, but this is way cooler because it's in real life, right? So, I built it because I had some empty wall space. So those are the best reasons. Just to do something because, right? But yeah, that is insanely cool. Yeah, so this is kind of, you know what would be cool if you see if you had like an animation of the forward pass, backward pass, right? I think you kind of see it. You know, like you notice how the blue moves forward. So you know that when we train a neural network, it has a forward pass and a backward pass, right? So it would be cool to see like the data flow through and back in the model, in the neural network. That's really cool, though. Synthetic data. Logistic, hidden layer. That's pretty cool. Awesome, awesome, awesome. Oh, sorry. Whew. So actually, we already got quite far, right? So this is already quite a. Of course, it's not as pretty, but it's not as pretty, but it does the job right now. Okay, so because of my constrained time, I'm just gonna skip the break and I'm gonna set another timer, and we're gonna just start working again. So so what is the one thing that I want to accomplish in the next session? In the next session, I want to get the two functions right. So I want to get red and blue into the unit square. What's it called? Hypercube, right? Or unit hypercube in just 2 dimensions, whatever. And if we did that, we can maybe even start trying to work on the neural network. How will I get started? Just fiddle around with the scale parameters. Internet, phone, the usual. Yeah, so looking at this with the red one is a standard cosine, right? So the translation, let's say the red already is half, right? So let's make that a fourth. Let's scale it down a fourth and translate it 1 upwards. And let's see what happens then. That's a bit too high, which is odd, because it's a standard. If you scale it with a fourth, it starts. If you scale a cosine, am I being silly now? So let's write that down. So if you have a standard cosine, right? Cosine goes from 1 to -1, and you scale it with a fourth, so a 1 becomes a fourth. and this becomes minus 1/4. And then we can use it, go it up and put it up 3/4. So we can put it up 3/4, 3.0 actually. And we can shut this down. Then we can run it again. Okay, okay, so that's good, right? That's awesome. And now we have to think. So we kind of want the other one, say, to start at like a half. But if we wanted to start at a half, then let's see, what do we need? So usually it starts at 1, right? Say we scale it to a half, but then it also is minus a half. And if we then scale it a half up, then we just start at 1, which makes it not separable there. So if we scale it down to, say, a 1/4, but then we translated this up 3/4. So yeah, we can do it a 1/4, and then we just translate it up 1/4. So let's just also do it a 1/4, and then we translate it up not 3/4, but 1.0/4. Just to get some random numbers, right? We could think of nicer and better functions. So this should work. Awesome. Look at this. So this actually, I think it is linearly separable. So this is, exactly this is what we're going for, right? This is the goal. Well, this is kind of the end goal of the stream. Like, look, we're actually getting close already. Except for the fact, of course, that... Oh, I just dropped something. Except for the fact that this decision boundary, we want it to be generated by the output of a neural network. So all that we have to do now is, well, we can always make it faster. You can always make something better faster, but we have to get it to work in the first place. So what we want to do now is we want to we're gonna need to train a neural network algorithm, and we need to embody the algorithm with a prediction. So it should be able to predict this is a 0, this is a 1. And if you recall from the first stream where we built the neural network from scratch in this file, it actually doesn't predict a 0 or 1. It predicts a scalar value. So we can threshold that ourselves, right? So let's copy this code instead of should we copy it or import it? Okay, okay, so this is in general what I'm gonna do is bad practice, but or do we have it already? No. So let's call this neural net, and let's not do it in this one. Let's open it here. Let's first quit this thing. So open neural net, and then we're gonna get rid of all the comments. Get rid of all the comments. Which is in general not a good idea, but hey, all right, so we don't actually care that much about this, but that doesn't matter because we're not going to use it as a main, right? We are not going to import it as a main. The only thing we're going to import neural net. So we can now just type import neural net, and it should theoretically still work. I'm gonna get rid of this plotting thing because I think it's annoying. So what am I plotting there? Good question, huh? Oh, print x red. All right. Let's see. Let's think. Think. So we did this actually. Next up, make training data. Yeah. So let's try and instantiate a neural network. Is this the way to do that? No. You have to import like X and Y, right? But of course, for that you need X, so you need Y. And now we are here. So this is exactly what we have to do with the training data. So I'm doing this in the wrong order actually. So we have to add this over here. So let's make this a training data. And then we instantiate the neural network, right? But here the training data. So X and Y. Okay, now we have to think a bit. Because the Y is actually I actually named that improperly. It's not Y, it's the labels, but it's like it's the labels, and the labels are 0, 1. So and let's consider the shape. Also consider the shape. So it's how do you say that? Not a row vector, but a column vector. So Y, or the label, is a column vector. That's a call vector. Should be. And this should be like, so we need to stack like multiple things on top of each other. And you stack like probably like NP like MP1s or something. Oops. So let's stack some NP1s. Let's see if this results in something useful. NumPy 1s. So shape MP1's 5, MP1's okay. So what I'm gonna do is I'm gonna make labels is NP array. I'm gonna initialize it empty. Then I'm gonna say labels is NP append, and then I'm gonna say labels is NP append again. I'm not sure if this is actually proper practice, but I don't care. I should care. Then we do MP1s. Let's just start with 1. MP0's 1. And let's print labels and see what happens. What error we get. Print labels, unexpected indent. So labels should be 0, 1 now. That is proper. That's good. Okay, but we want like sorry. Sorry for that interruption. Sorry, my bad. I'm just gonna check my sound real quick. Hello. Okay, so the sound's working. Okay, so I need to shape. So what I'm gonna do is I'm gonna make a row vector and I'm gonna transpose it. So we need the shape of the y1s. So let's take y1 shape not. Let's print it first. So print y1 shape not. Oops. That's 100. So that's good. So we can do that. We can put it here. So we can say, okay, that's y1 shape not. And then we can call this y0 shape not. And this should be then a 200 by so a 1 by 200. But now we can transpose that, right? So now labels is labels t. And this is not what's supposed to happen. This should, okay, so what I want is, it should be a 200 by 1. But it doesn't print a shape. So, it should be 200 by 1. So it's 200 by, okay, but what if I don't do the transpose? Is it then a 1 by 200, or is it then a 200 by something as well? Okay, so it's just a 200. So I think NumPy doesn't care whether something's a row or a column, I guess. But I'm gonna transpose it anyway, but I'm gonna add like a warning. Shape equals 200 by naught, or 200 by, I don't know. Okay, so that's the label. Now all we need to do is stack the x's and the y's. So now we need to create a 200 by 2. So we need to make like, we need to zip together the so now we need to like zip together x range and y1, and then again x range and y naught, and we got to zip them up. How do you do that? Can you zip two arrays? So how to zip two NumPy arrays? How to zip 2D arrays. How to zip 1D NumPy array to a 2D NumPy array. Alright, so we want to look at this. I'm just going to copy this real quick. Wait, that's the wrong copy button. Alright, let's copy that. Copy, roger that. So let's copy that. Things we've learned. Or sources we consulted. Which is very important. So the list zip. The answer lies in your question. Please note that list. Does it keep? Excuse me. I'm gonna go for dstack actually. But so let's think about this. Okay. So what we now want to do is we want to get two X ranges after each other, and then we want to, so pay attention. So let's say we have X and Y. So we're gonna, so let's initialize both of them. Okay, and now we are, first, we're gonna stack them together. So we are gonna do MP append X range. We're gonna add it twice, so you get like so X equals then an array which has like X range. Then we are going to make a Y that has Y1 and Y naught. So is NP append Y and Y1. y equals np append y not, and now we are gonna zip them together into one big data matrix or array, whatever. So now you get like x. Okay, so this is actually really annoying because okay, so this is really bad practice actually. Please don't copy this from me. Cuz okay, no, I'm not gonna show you guys bad practice. So how am I gonna use okay, I'm gonna call it training data. That seems like a good compromise. I was planning on calling this just like X and then zipping them together like MP array, not in the list but with a D stack. So MP D stack. And then tupling the X and the Y. But I have changed my mind. I'm gonna use training data because I don't wanna. Okay, so the question is, what error are we gonna run into? No error. That's a pleasant surprise. But I want to check the. Oops. Let me see. I want to check what this kind of looks like. So it should be like. It should. Yeah, this is exactly the way it should be. That's really nice. Is it though? Yeah. No. No. This should be 200 points. These are not 200 points. Or, right? Or, okay, so let's... It should be... Oops. One. It's 1 by 200 by 2. So first dimension numpy is 1. So I saw an autocorrect which said remove first dimension. So remove first dimension numpy. Numpy squeeze. Removing length. What's the easiest? But we're very close because now we can. So exactly. So awesome. So we can write that down, what we have learned. So let's write that down. MP squeeze, right? So things we've learned. Remove first dimension with MP squeeze. Where are we? So training data. So let's print the training data. And now we have to ask ourselves, does it remove like, does it return or does it actually remove it? So training data, print training data shape, and then we're gonna do a training data squeeze. No, wait. MP squeeze training data. And now it should be better. It's not better. Because it probably returns like, yeah, it returns the squeeze. So we have to do training data. So it doesn't like, it never changes stuff in place. And I think that's Pythonic. That is Pythonic, right? Not changing stuff in place. But we're almost there. Well, almost there is an overstatement. But we're inching closer. We are inching closer. So we did that. And now we can initialize. We can initialize the neural network. So here we are actually gonna create. We're gonna create, or yeah, we're gonna create the. Okay, now let's see what error we get thrown in our face. Neural net is not defined. But we actually import neural net, but we imported that, so we should be able to use the class. Does anyone know? Can anyone help me? Why can I not? So I import neural net, right? That's the name of the module, but I cannot use neural network, which is a class in the other file. Why not? Right? I should be able. Right? So here we have neural network, and here we have neural network. But I can't use it. Isn't that odd? Maybe do from neural net import neural net. All right, let's try that. But this should import the whole module, right? All right, maybe that. Thanks for helping me, by the way. Oh, import. The name label is not defined because it's labels. Let's see, tuple outer range. Okay, so it does work, right? Self input shape 1. So the input shape is equal to like X shape, right? So let's see what that returns. That is a 200 by, but then if we like put a 1 in there, then probably we get an error because it doesn't have a second dimension. So what have we learned? We have learned that that like a 1D array does not have a second dimension, which is actually kind of makes sense, right? So if you have like 200 by naught and then you type shape 1 is an error. But that is weird because our input shape should not be one-dimensional. It should be 200 by 2, right? So something's going wrong, and if we print X, we'll figure out what is wrong. So if we print out the X shape, so this is our, oh look, it's flattened. It's, oh, of course. You guys are not paying attention, are you? Because we need to do training data. This is exactly the reason that exactly the reason I use training data. All right, so let's see if that works. That works, and it is, we instantiated it. So we are almost there. We are like really close. Because now all we have to do is train it, right? So all we have to do is train it. So let's say for like 100. All right, let's see if this works. It doesn't. Uh-oh. Did we hardcode stuff? Let's think. Backpropagation gives an error. Line 25 gives an error. D weights 1. NP dot self input T. NP dot self dot Y. Self output sigmoid derivative. Self output self weights 2. 200, 200, and 1, 4 are not aligned. So I think that we have to look at the dimensions. I think we have to look at the dimensions of the... So that's 200 by 2. Print shape labels. This should be 200 by... So the shape 200 by 200 is not like so we get a value error shapes is 200 by 200. Now my question is, what in the world is there that needs to be 200 by 200? Like nothing needs to be 200 by 200. So sadly I removed all the comments, which was really dumb in hindsight. So this of course is times 4. 4. See? 4 is hard coded because we have 4 no way. So wait, is it hard coded? Wait a second. Wait a second. Color me confused. Because we have like okay, let's go back to the drawing board. Because our neural network looks as follows, right? So we have two hidden nodes for X and Y. Then we get 4 hidden nodes over here. And then we have 1 output. Right? So the weights are then 2 by 4. Okay, so So the weights are 2 by 4, which I can agree with. So I have like 1, 2, 3, 4, 1, 2, 3, 4. Those are those weights. Then you have these weights, which are 4 by 1. 4 by 1. Why are those 4 by 1? So weights 2 are 4 by 1. Where's my mouse? It's 4 by 1, huh? 4 by 1. So this is 2 by 4. Shit, why didn't I make this go better? Okay, so now you can see what bites me in the ass is that kind of the shapes and stuff. I don't want to say are messed up, but we have to go over them again. Maybe because I deleted the comments. So, okay, so let's think about that again. So we got an error. What is the error? We got the error in updating the weights of the first backpropagation. And we had a 200 by 200 error. So what we could technically do is just run by all the dimensions of the individual weights here. So let's close this split and just check all the dimensions of all the weights. So Let's print self input t, self input t shape. Print self y shape. Print self output shape. Print self weights 2t self weights 2t shape, and print self layer 1 shape. All right, so we should be able to print this out before we run into an error. So okay, so let's see. The self input should be 200 by 2. That's the first thing. Then what is 200 by 200? 200 by 200 and 1 by 4 are not aligned. Oh, this is... So, okay, so let's... So what should the weights be, right? So, so the dimensions... So the dimension should be... So the dimension should be... Come on. Weights. Self weights. The dimension should be, third time's a charm, should be 2 by 4 and 4 by 1. Okay, so let's write that down. Let's write that down because we need that. So we actually wrote that down already, but let's write it down again. So in the end, we want a matrix that is 2 by 4 and a matrix that is 4 by 1. Don't ask why I made this a 4 by 1 and this a 2 by 4. I think it is consistent because this is the amount of hidden nodes here, and 4 is the amount of hidden nodes there. Then we have 4, which is the amount of hidden nodes input, and then we have 1, which is the amount of hidden nodes output. So in that sense, it's consistent. So, so that is what we are looking for, right? But now the problem is that the dimensions don't align. So we are gonna have to debug that in a very painful way. So, okay, we have, so let's, I don't want to say make a new layer, but let's make a new layer. And let's start over again. Well, let's not start over, but like, let's have a nice clean sheet. So I didn't delete anything, don't worry. So let's have a nice, nice yellow. And in the end, so we want like a 2 by 4, right? So now we are gonna check. I'm gonna actually, yeah. So okay. So let's. So what are we doing first? I think the first thing we evaluate is the self y minus self y output. So that is the can I copy this and paste this in Photoshop? That would be pretty cool if I could do that. That's too big. Let's make it really small. Paste it in white. But I want everything. I don't just want like, I want everything. copy. Okay, wait, maybe if I open it in MacFim real quick. So we are looking for, oh wait, no, it's in a neural net file. So what I want to do is I want to, oh wait, I can just make a screenshot. Oh, of course, can just make a screenshot. So let's make a screenshot. I want to like write all the dimensions in there, so to see which dimension is just like you're debugging math, right? Or well, you don't call it debugging math, just like checking your calculations is you painstakingly go over each individual dimension. Is it this one? Oof, the quality is horrible. So let's see if I can make this any better. Yeah, no, that is a bad quality. So consider me puzzled. Where is my smaller screenshot over here? So let's try and import this, which is also horrible quality. But why? Why is the quality so bad? This is weird. Okay. Maybe it might even help that it's bad quality, because then we have to focus harder on what is written there. All right, so let's start with self output. What's the shape of self output? Self y is 200. All right, so maybe it already starts here. So self y, let me get a brush in there. Self y is 200 by 0, and self output is 200 by 1. So my question is, what happens when you put those two together? Because we have to because we like what happens when you take this, right? So let's say TMP equals that, because one of them is like 200 by 0, and this is 200 by 1. So let's print TMP shape and see what happens. Oops. So look at this. So we get a 200 by 200. So we found our error. We found our error, guys. So that is exactly where the error lies. And like, I don't want to say I told you so, so I'm not going to say that. But this is how you debug. You painstakingly go through every single line that you ever wrote until you find something, and hopefully you're a bit faster next time. So we found the error. So we actually should write that down. We should definitely write that down, because this is something you can really learn from, right? Like self y minus self output were 200 by 0 and 200 by 1. What's the English word again? You can't add them, but you subtract them. Can't subtract. It is 200 by 200. So now we need to do the opposite of squeezing. So now we need the opposite of MP squeeze. Now we need to add a dimension. Expand dimensions, I guess. MP array. So see, new axis. Yeah. So okay, but let's make it in axis 1. So what have you learned? We have learned that NP squeeze, like NP expand dimensions, is the opposite of squeeze. So which we can make it 200 and turn it into a 200 by 1. That's the idea. But this confuses me, because then why didn't we get an error when we first ran this piece of code? So self y is 200 by So can we like make like a new axis, like np, so self y, does this work? It's not pretty. Global name new axis is not defined. Boom! Oh, look at that. Look at that. It's training, boys. Look at that. It's training. There we are. Success. Great success. The biggest, the best, the biggest success. So I'm gonna make a small comment here that we need to expand dim. So we actually found the what? Well, we figured out that we needed to add an extra dimension. So we went over all the dimensions in Photoshop. Well, actually, just the first one. Yeah, so we got a bug. So this thing was 200 by nothing, and this was 200 by 1. And it turns out that you cannot subtract these two, because that results in a 200 by 200 matrix. What you need to do is you need to take the 200 by naught, or 200 with no dimension, and then you need to expand that to a 200 by 1. And then you can subtract it from the other 200 by 1. But otherwise the dimensions get mixed up here. So that was what we were missing. But now we did that, and now we can just can actually get rid of all of this. Well, I'm not gonna get rid of it. I'm just gonna copy comment it out. But now we trained it for like 1,000 iterations. Let's keep it 100. Keep it at 100. And I think I should almost be done, right? Oops, there's a Spidey, bro. Oops, there's a spider. No, wait, that's not a spider. Oh, that's a timer. Look at the perfect timing. But I kind of want to finish the decision boundary because I'm really excited. So I'm gonna continue past the timer. This is not, so we're almost done. Like, the only thing we have to change now is find a way to predict. So we need to let's go back to the neural net code. Let's make a vertical split and go back to the neural net code. So all we need to do now is predict. We need to pop in and predict. So let's try and see if we can NN predict in here, where X test is like an X and a Y. Hey, just me, bruh. If you miss something, I tried to cover it again, but if you still feel like you missed something, always feel free to ask it, right? Always feel free to ask in the chat. I'm more than happy to explain it again, or just give a quick recap of what I've been doing, because I think this kind of stuff is really exciting. So what kind of error are we running in? We're not running into any error, but there are a lot of numbers. Oh, wait a second. Actually, I was thinking that these numbers are wrong, but these numbers are actually correct. So let's print a shape here. And and the shape of this number. Wait, I'm doing all kinds of stuff. So let's run the visualization algorithm. So okay, so that is not good. So we predict a 200. That is not. So let's see what print x. Print xy. So let's see what xy looks like. Okay. All right, so that makes sense. Oh, we're so close. I can taste it. We are so close. Let me think. 1 second. So let's put this decision boundary to like 20. And this decision boundary also to 20. So that's a factor 25 faster. We want to put in a single observation, a single array. Oh wait, maybe we have to put in an array. So let's try print like nn predict, and then np array, and then we add just a list of x, y. So let's see. This is like data like xy. And this is like the prediction. So prediction. Right? Alright, so let's check that out. Oh, oops, it's still going strong. Alright, so we can definitely try that, I guess. Oh, ooh, ooh. Okay, I got an error. Prediction. It's a typo. That of course should be an ND array. No, I'm not sure if this is correct. This is not correct. This is... Why does it give back a 200? It should not give back... Oh, wait. Maybe it's exactly the same problem we had, right? Maybe we get exactly the same problem with the shape. So we have possibly exactly the same. So let's print x shape. So let's look at the shapes, right? So print self weights 1 shape. And let's see, let's print zpred shape. And then here we have print self weights 2 shape. And then in the end we have print prediction shape. And now I should it can immediately cancel this already. Look at this. So exactly the same problem. Exactly the same problem. So I'm gonna write this down again because this is something that is like a recurring theme. So we ran into the same problem in the prediction phase. So that's actually really important. Well, really. So notice how so the let's see, the input is 2 by something, then 2 by 4, 4 by naught, and then we have 4 by 200. So we need to add a new dimension. We need to expand, like, so x equals x, where we add like what's it called, np new axis. So now this should be 2 by 1. Uh. All right. No, wait. Of course not. Of course not. This should be like it should be a. Okay, so I'm kind of banging on the. Okay, so it's still not working, I think. So I'm kind of. So, like, dimensions are still like not correct, right? Shit. Okay, so I'm gonna put a breakpoint. I think you can put a breakpoint here, right? Break. Just stops executing, so all right, break outside loop, so that doesn't work. So the problem is that okay, so prediction is 1/2. Then we have a 2/4. We have a 1/4, a 4/200. Okay, so that 200 is not correct. The 200 should not be there because the weights, just the weights alone. So how? Like, okay, so let's go back to the drawing board. So, in a neural network, hello, in a neural network, hello, where is my Photoshop? In a neural network, Photoshop is does not want to cooperate today. Hello? Photoshop? I need your attention. Okay, can I open Photoshop? I can open Spotify, but I want to open. Come on. Here we are. So in a neural network, you have like I think my computer is having a bit of trouble. I'm patiently waiting for my Photoshop to say hi again. Okay, so if we can't do it with Photoshop, we'll just have to think it through. So, so you start with 2 nodes, right? Then I'm gonna just grab a piece of paper because using a Mac. Yeah, I know. Sorry. I tried streaming from my PC. So the last stream, I hope you tuned into that. We actually got a GAN working. We managed to get a GAN working in a collab, in a Google Collab notebook. And the images that we generated, I mean, they didn't look like anything, but we did get a GAN working, so that was really exciting. Imagine you have 2 input nodes, right? Then you have 4 hidden nodes. I'm drawing 4 hidden nodes, just on a piece of paper, and 1 output node. So you always stack the observations in like an n times k, where k is the amount of features. So you have a 1/2 matrix that you start with, right? So that's your data. That's the xy. Then the weights are 2/4. And let's go back to the code, because we need to predict, right? So the self weights are 2/4. So we can actually write that down. We can write down like, excuse me. We want x to be, x should be 1 times 2. Then self weights 1 should be 2 times 4. And an NP dot gives a z prediction of 1/4, right? So we should see that back in the, so the 1, 2, 3. So z-pred shape is the third one, is indeed a 1/4. Then we do the sigmoid of the z-pred and the self weights 2, where the self weights 2 are 4/1. So self weights 2 are 4/1, which is not true. Which is not true. I repeat, z self weights 2 is not 4/1, but instead it's 4/200. So something went wrong there. So our self weights 2 are 4 by, so that should be 4/1, and then the final thing should be 1/1, but that's not what happens. What happens is our second set of weights is also wrong. And why? Probably because of the same reason that we have a self y here, which we didn't specify with the new axis. So again, the third time's a charm, we run into exactly the same problem. Actually, the prediction problem stems from weights 2 having the same issue. We have to change self y. I have to change it into self y, and then adding a new. And I'm like 40% confident, or maybe even a bit more, 60-70% confident that it's gonna work after this. But of course, you can never know. So we add this, and now I am hopeful it'll work. I'm not sure if it's gonna work, but I'm hopeful. Very good, very good, very interesting. Did you see that on the? Do you see that on the background here? All right, so this is exactly what I wanted to show you guys this stream. I'm not done yet, but we're close. I'm just gonna continue working because this is very exciting stuff for me. I hope it's exciting for you guys as well. So let me shut down all these tabs. So let's go back to the tutorial. So this was the goal, right? Can I make it a bit smaller or something? Yeah. So that was the goal, to get that kind of picture, and we are at the moment at this picture, but now we can fiddle with the parameters. So let's actually let's increase the amount of iterations to 1,000, and let's set this to 100. And then we set this to is 100 already, but the number of points. So let's say num is equals 100, and then let's change this to num. All right, so plotting. Let's see and wait. I should probably comment this out. I should probably comment this out, because now it's gonna do 100 times 100, which Wait, of course. We didn't add anything. So notice how it's predicting a half. Notice how it's predicting a half everywhere. That's a bad sign. No, wait. Is it a bad sign? I'm not sure. So we can get rid of all the printing statements here. And now the very final thing that we have to change, is this. So okay, so think. So the red label is 1, which is high, right? So if we predict a high value, so let me make a threshold equals a half or 1.5. So if we predict, so okay, now this is the very final thing we have to change, and then I have to go, well, then I don't have, yeah, I do have to go, but also I think it's finished. So if we predict a value larger than the, is that how you spell threshold? How do you spell threshold? Threshold? Threshold. Right? So if you predict larger than the threshold, where this is an NP array. Okay. Moment of truth, guys. Let's go. Oof. So it's it's predicting blue everywhere. Does that make sense? Shit. Okay, so what if we put the threshold to like very small, right? And why does it keep returning the shapes? Is it in the, oh yeah, it's, all right, so it's in here, right? Keeps returning all these shapes every time the function gets called. So let's try that again. So now I put the threshold to be like really small. Okay, so notice that the loss is really big. Like the loss is like really big. That's really bad actually. But why is the loss so ginormous? The loss is like really big. Did we do anything wrong here? I sure as hell don't hope so. So this is 500,000. Okay, so let's set the so let's change the threshold back to 0.5, not 0.5. Is it only return integers? The loss function. That's a good question actually. Let's set this to 100,000, 10,000, and then loss. So let's see. NN loss, which is in the NN file, right? In the NN. So NN loss is about here. NN loss is 0. NN loss. Oh, look at that! Look at that! Again, we run into. So where did I use this more, right? So Now the question is, where did I use it? Everywhere. So again, the same issue. Man. So the loss is ginormous because, so that's so weird. But then I wonder why I didn't get that error. So I definitely like, this is bad practice, right? We should completely rewrite this code, but we're kind of pressed on time now. So look at that, look at that, look at that, look at that. It's going down, but it's still bad, but it's going down. So we were able to reduce the loss from, I don't know, like 1 million to 25. So let's give it a bit more time to train. Let's give it 50 times more? 500k iterations? That should be enough. Who got time for that? Casual turnip guy. So 500k should be decently fast. So let's put it... Should be decently fast, right? 500k. So that's 50 times this. So let's count. 1, 2, 3, 4, 5. So it does 20k iterations per 5 seconds. 20k iterations. So that's 100k per 10 seconds. So it's like, I don't know, like 1 minute. The loss is not really dropping anymore. The loss is not really dropping. That's odd. Is it not? Okay, I really have to go, actually. Fuck, I really have to go. Okay, I have to go, but we will definitely finish this because it's just trading in the background. So it's trading in the background, and I'm gonna have to debrief myself. So get red blue unit into hyperloop. We did that. Timing is let's say 21:20, and 1 second. I was saying stuff. What did you do this cycle? Actually, we almost finished the project. So we managed to get the neural network in and stuff and stuff. Any distractions? I don't have time to fill this in. I don't have time to fill this in either. So what did I get done today? We actually got done a lot. So we plotted some functions in pyplot. It's still not really what we're hoping for, right? We plotted some function in pyplot, then we kinda tried to fix the neural network, and we ran into some issues in the dimensions. How did this compare to neural network? It was fine. I mean, it's not particularly productive, but that's always the case in the evening. Where did I get bogged down? Yeah, kind of like debugging math stuff, but not really bogged down anywhere. We just needed to work through stuff, right? What went well? The chat was very helpful in finding some bugs. I saw some regulars, which is very nice always for me. Any other notes? Kind of pressed on time. So I really have to run, guys. Thank you so much for tuning in. So what did we do? So I'll just quickly recap if you wanna like rewatch the VOD. So the goal was to kind of visualize the decision boundary for a trained neural network. That was like what we started with. That was the starting goal. Why? Because I want to make like a kind of a YouTube video and show how the decision boundary of a neural network kind of evolves over the time. I think that's really cool. So this was the very first picture that we drew, and we end the stream with this picture, which looks close, but is not really, because so our algorithm, so we can visualize the decision boundary, but just the problem is that our algorithm just doesn't work. So next time we're gonna fix the neural network. We're gonna make sure that it is able to predict red and blue. Yeah. So that's for next time. But we got really close in just 3 hours. So I'm really proud of us for doing that, and I'm really glad you could all join me today. And hopefully you guys tune in next time. I am so sorry I don't have a regular streaming schedule, because sometimes I wake up and then I think, oh nice, I feel like streaming, and then I stream, right? And sometimes I don't feel like streaming and I stream, or sometimes I feel like streaming but I can't stream. So tomorrow I'm really sure I won't stream because I'll be busy all day, but probably this weekend again. So hopefully I'll see you guys Saturday or Sunday. Yeah, I had a lot of fun. I hope you guys had a lot of fun, and yeah, I was just so glad to have you guys, and hopefully see you guys next time. So don't forget, if you like this content, don't forget to follow me. You will get a notification when I come online, and it helps me a lot by just kind of giving me like some extra motivation to stream, right? So I'm gonna save this in the visualize neural net. So this is a stream 11. So stream 11 drawing. I'm gonna shut down Photoshop. Yeah, and then I want to thank all of you for joining me today. It was so nice seeing you guys. Some regulars, Vindolanda, just me, bruh. Discord. Yeah, I should have posted on Discord. I was pressed on time. Did I post it on Discord? I think the Discord's in the channel description. So we have a Discord. You can join it. I try to be active, but I've been really busy lately. So yeah, Greenie, just me, bruh. Yeah, Vindolanda, push up egg. I don't think you followed me yet. Ryagami did follow me, so you want to kill me also. Thank you guys so much for tuning in today. I had a boatload of fun. Hopefully you guys had fun as well. And I really gotta go now, so I'm gonna stop the stream again. So thank you so much, guys, for tuning in. Hopefully see you guys next time. All right, see ya.